All right. Thank you, guys. Appreciate making it here after the big switchover. Appreciate the intrepid adventure that you've been on. So my name's Doug Smith, joined by Piotr, and I am one of the maintainers of Multi-CNI, which is a meta plugin for CNI that we'll get into that. And I'm also a member of the Network Plumbing Working Group that works on plumbing multiple interfaces or network attachments, as we like to say, into pods and Kubernetes. And Piotr, an introduction?
And I'm just simple Kubernetes contributor, and I'm also working and maintaining on CNI. So it will be also mentioned today.
All right, so here's a quick agenda. We're going to talk about CNI multiplexers. Some of the plugins that we will talk about live on kind of a spectrum of what's strictly a multiplexer. So we're going to talk about these other approaches. We'll talk about network attachments as a theme. And then we're going to talk about some native object proposal that Piotr has presented for us. So why do we really care about having multiple network attachments? Sometimes what we get in the world of Kubernetes is a focus on web scale applications. And in web scale, all you care about is just some traffic going out and getting traffic back. So your pod has this one singular network attachment that looks like an interface in your pod, and it just attaches you to everything. But once you start looking at workloads that are network specific, you have different type of architectural considerations that you need to manage. And what I've illustrated here is this idea of control plane, data plane separation. And when you just have that single interface, you start to ask the question of how am I going to approach this problem? So we're going to talk about some of the approaches that are used.
So basically, introduction how networking is working in Kubernetes. Kubernetes knows almost nothing about network, which is prepared by system operator on the nodes on which the part of Kubernetes which is working is kubelet. Kubelet is not configuring networking for pod. It's asking for that runtime. And that runtime could be containerd, Docker shim, or even Virtlet for virtual machines. So everything what could speak using CRI, what means container runtime interface protocol. And this runtime, when it's asked to prepare pod sandbox, which is place where pod containers will be running, is somehow configuring networking. That's how it's done is dependent on the runtime. Most runtimes are using CNI. CNI, what means container networking interface, and it will be discussed later. But it's not a hard dependency, so it's up to implementer of runtime how it's done. In effect, Kubernetes knows only about single IP, and it's interested only about single IP for the pod. And it's not always what we expect, because we have bigger needs. Basically, I said already about this assumption. So Kubernetes is expecting from runtime that it will add to pod some IP address, and that it will be available without any network translation, NAT. Every pod should have a possibility to see everything on the cluster. So all services on nodes, services exposed by Kubernetes. And in most cases, that's configured by CNI. So that can...
Yeah, absolutely. So something that we'll talk about a lot is CNI, which is the Container Network Interface. And really what CNI is it's an API. It's a way to describe how you can make a pluggable framework in order to extend the network capabilities of a container platform. CNI itself is platform agnostic, so it's not purpose-built for Kubernetes. It's for any container platform. However, Kubernetes does implement it. And some of the things that we really like about CNI is that it's really easy to use. If you can have a programming language that can talk standard in, standard out, you can use it to interface with CNI. Now granted, most of the time you'll see CNI plugins that are written in Golang, and this is primarily because the maintainers of CNI have made some really great libraries for us to use that makes it easy to leverage. Something else that we really like about CNI as well is that it allows us to offload the kind of network intelligence that you need away from Kubernetes and into your own specific plugins. So you can get plugins that are made by you, by your favorite vendors, and by the community, instead of having all of that knowledge packed right into Kubernetes itself. So you can meet your specific demands for networking in particular. So just to go over a quick example of a reference CNI plugin, this one goes over Bridge. And basically the flow of what happens is that you'll have a container runtime. It's going to call CNI, which in turn will run your plugin. And there's going to be a series of variables that are sent along to the CNI plugin. It's going to contain an entire configuration. It's going to contain your container ID, and it's going to contain a method or operation that's currently being performed, such as add or delete, and there's a number of other methods that are there. Then, once your plugin runs, you basically are free to do whatever you need to plumb your particular pod. So in the case of the Bridge CNI, essentially it takes that container ID and it'll create a bridge on the host node, and then it will make a VETH pair between, so that's a like virtual Ethernet connection between your pod and the bridge on the host, and that'll be presented as your typical Ethernet device inside your pod if you were to execute IPA, for example. So let's just take a quick look at what a CNI configuration looks like. And primarily, they're intended to be mostly a free-form JSON. So when you go to write a CNI plugin, most of the fields are for you to determine what you'd like. So in this particular example, there's a few of these that are required by the CNI specification, primarily the type field. And what that says is this is the executable that is your CNI plugin that you'd like to run. And also the CNI version, which helps with compatibility between versions of CNI. The IPAM is also kind of a special type of CNI plugin. That's like a CNI plugin that can be run to perform IP address management. That's where our IPAM comes from. And the rest is up to you. So for example, in the bridge field that's there, that's specific to the Bridge CNI plugin, and it will denote the name of the bridge device that's created on the node. So you can use those essentially in a free-form fashion. So let's talk a bit about CNI multiplexers, which is getting into more of the core of what we came to talk to you about. So a CNI multiplexer is also sometimes known as a CNI meta plugin, and we say it's a meta plugin because it's a CNI plugin that can run other CNI plugins. So that's kind of the strict definition of a CNI multiplexer or meta plugin. So on the left here, what we've got is we've got your runtime, calling what we'd say is a default CNI. So like a CNI that provides pod-to-pod connectivity that allows your pods to communicate over the network to other pods. So it calls your default CNI, and then it's going to plumb that pod with an ETH0, right? So that's where we get this one interface that we see. Well, technically, if you go into a pod, execute IPA, you're going to see a loopback and an ETH0, right? So that's what you've got by default. So one of the solutions to plumbing your pod to attach to multiple networks is to use a CNI multiplexer. So on the right, we've got the CNI multiplexer being called by the container runtime, and then it's going to call your default CNI, so you still have that pod-to-pod connectivity. Then it's going to call n number of additional CNI plugins in order to plumb additional interfaces. Or in the case of technologies that don't use a traditional, Linux kernel type interface, it may perform other actions, like say it's for user space, like a DPDK, et cetera. It may not present itself that way, but it can do whatever plumbing it needs to do. Something that we'll talk a bit about as we continue the rest of the conversation here is about custom resources. So this is something that's used heavily by a number of CNI plugins that perform this kind of functionality. And the kind of fancy way to talk about custom resources, pardon me, is to say that custom resources are an extension of the Kubernetes API. And to me, that sounds pretty highfalutin, when really what it comes down to in the end is a pretty simple thing. It's a way to store some information in the Kubernetes API and let your application query for it. So it can provide as kind of a lingua franca for your applications to speak amongst themselves. So on the network attachment definitions, this is something that's a standard that's been proposed by the Network Plumbing Working Group. And essentially the idea is to create this way to express that you'd like to attach to multiple networks. And the reasoning behind creating this type of specification is to create a more uniform user experience for people that are using these kind of technologies. So this way, if the technology changes behind the scenes, as a user, that's really annoying for you if you have to change all of your configurations to a different kind of standard. So this kind of idea is to say, hey, let's come up with a community accepted de facto standard that lets you express, hey, I'd like to attach to multiple networks, and you can let the technology behind the scenes perform the dirty work there instead of putting that right in the user's face. Multi-CNI is a CNI multiplexer. It's a meta plugin. I am one of the maintainers of this particular technology, and it is a reference implementation for the working group that came up with network attachment definitions. And kind of the core behind it is you take a CNI configuration, so that's that kind of free-form JSON that I was talking about, and it's packaged inside custom resource. So since that custom resource is stored in the Kubernetes API, it can be accessed from any particular node, and it allows you to say, hey, this particular configuration in this example, it's for Mac VLAN type CNI plugin. This is what I would like it to do when that additional interface is attached. So it's really focused on being able to attach any arbitrary CNI that follows the CNI specification to a pod.
So next example for multiplicator is CNI Jenny. It has several modes of working. That's example how it could configure what should be attached to pod. So it's configured by additional annotation, and in this first simple case, it's using its custom annotation named CNI, in which you have a comma-separated list of names of configuration which should be attached to a pod. And this case is also interesting because with this list, you can skip default network configuration. So you can configure your pod to have an access to your private network, which is somehow disconnected from Kubernetes API. That's the possibility, which is non-standard for Kubernetes, because normally Kubernetes expects that pod will have IP which is available for the rest of the cluster. So we have this custom CNI annotation, and if we define another multi-IP preferences in the form which is presented, it will be filled by CNI Jenny with information about what was really added to the pod. So that's the way to inform what was really configured, because in a normal pod status you have only a single IP. So that's the place where you will have full information about different IPs. Another option is to use network attachments. So in case of network attachments, the configuration which is shown there, so it's based on other name for annotation. And this example will work also with Multus. That's the why these network attachments were prepared, to have a common way to configure, even if the technology under the hood is different. And it also have this name for networks, so that's the name of network pod attachments configurations as shown by Doug, and also additional annotation for status and information, what is really configured for that pod. So maybe.
Another technology that acts in a similar fashion but is different is Nokia's Danam. And something about Danam that I think is interesting is that it provides maybe a more opinionated way about how to attach to multiple networks. So instead of having arbitrary CNI plugins that you can attach to, it has its own customized custom resources that speak about specific aspects of those. So what you trade off is flexibility for more of an opinionated way to attach to a network. So it exists on kind of a different part of the spectrum from a strict meta plugin. However, definitely worth looking into in case it fits your particular use case.
So there are also another option to configure multiple interfaces. One of them is TungstenFabric. It's a bigger project to interconnect with different types of clouds. So you can connect your Kubernetes to OpenShift, to OpenStack, to VMware, or other solutions. And it has a way like CNI Jenny to configure your networking using their custom annotation, but it also has a possibility to leverage network attachments. But it's not a multiplexer. It do the job on its own way. So it's not calling different underlying CNI plugins. It's doing the job on its own. Another option is ZT-Niter. It's also speaking CNI protocol, but most of configuration is done outside of CNI configuration files. And even if it's speaking CNI protocol, it's always returning result with information of configuration with hard-coded values. So which are incorrect in the time. So it cannot be used by all runtimes because sometimes runtime will expect correct values. For example, Virtualet for virtual machines will expect really what's configured on host, and this kind of hard-coded data will simply not work.
So I just wanted to speak for a minute about the network plumbing working group that came up with these this de facto standard for a network attachment definition. This was a community-founded effort that happened at KubeCon in Austin in 2017, and essentially there was kind of a bit of a frustration with how we could take this concept of multiple networks and how were we going to approach this as a community. So what we decided to do is we got together and we formed an out-of-tree solution for how to express your intent for this attachment to multiple networks. And I'm really proud of the work that our group has done. It's a easy to get along with group of guys and everyone else who joins the effort. However, I'd really encourage you to come and join some of our meetings this time of year. We tend to operate on kind of a KubeCon to KubeCon schedule, and some of the recent improvements that we've made over this last year is to specify how you could change your default network selection for routing to a default gateway. We've also figured out how to approach the use of CNI args, which allows you to specify on a pod per pod basis some exceptions to your general custom resource that you've used. And so definitely join up with us and see what's going on. We meet on opposite weeks from when SIG Network gets together, and probably around this time of year we'll start to figure out what our goals are for the next year. We have some goals that will overlap. We'll have some new stuff. So if you have considerations, we'd love to hear them, and we'd love your participation in the formation of these specifications and the reference technologies that we build. So we don't just make the spec, we also make the technologies, and we have this feedback loop going into it.
One another word to this network plumbing group. We have a meeting today, and 2 weeks ago I started some document about extending awareness about networking by Kubernetes. So I hope that with rest of this group we will be working on CAP for Kubernetes, how we could change Kubernetes to be more aware natively without using, for example, CNI multiplexers about networking, because these multiplexers are simply workarounds, and Kubernetes, after all, does not know about additional interfaces or IP addresses. So in the effect, it cannot leverage services attached to these IP addresses. And my proposal is about how to address this topic. So how to step-by-step extend Kubernetes, having all the time backward compatibility with current network model, but still with the way of extending it to provide an option to attach multiple interfaces and to have, for example, scheduler fully aware what's available on which node. So to schedule a particular set of pods on a particular set of nodes without using workarounds. So simply natively. So this is the list of URLs of technologies used in our presentation. The presentation is available on Sketch.com, so you can simply reuse these links. And also, there is a link to YouTube to some small demo about how you can switch on the fly where traffic should go using TungstenFabric. And under the hood, you have Kubernetes pods and OpenStack virtual machines. So you have a choice to switch on the fly from web interface where the workload should, or where the traffic should go. And basically, that's it. I see that there's some questions.
All right, well, just want to give the guys a big round of applause. Thanks a lot for the talk. And also would like to remind everybody that it'd be great if you would review the talk on sketch.com if you get a chance. And you know, with that, we've got some time for questions. We only have one mic, so I apologize, but you know, just the room changed at the last minute and everything. So I'll let the guys, you know, kind of pick people, but if you could speak up really loudly with your question, they'll repeat it so everybody can hear it.
Oh, to you in the front row.
Okay, can you put a slide number
10? Number 10.
Sorry, I didn't have which one's no?
Yeah, go 8 back. It's tiny in the bottom right. And this one, okay, yes. Yes, so you can, so that is, it probably should be diagrammed a little bit better, but that is intended to represent n number of additional attachments. And so there may be some dependency on the particular plugin that you use. However, it was certainly one of the first class considerations when we first started writing the specification was to say, I'd like to attach the same definition multiple times as multiple interfaces. So I've certainly seen community examples of that before where the same CNI plugin. I'm not super familiar with the OVS CNI plugin, but the way the specification is designed, it should work. And
Can I continue?
please.
So the specification says about configuration, and this configuration, this different configuration can use the same binary, which is under the hood. And this different configuration probably will have configuration for different subnets. But still, they can use under the hood the same binary, so the same plugin.
Cool. Fourth row, yes. To you, blue shirt. Yes, thanks.
Quick question. Is IPv6 networking supported on the CNI multiplexers?
And so oh, yes. So the question is IPv6 supported under CNI multiplexers? And the way that the specification is written, we have certainly considered IPv6 from the get-go and for each iteration that we've made on the specification. So just as a quick example is we made a proposal that we accepted recently that was for default route selection. And as you read through that, you'll see how we addressed it in order to account for IPv6. So for example, under IPv6, you can have multiple gateways for a default route. So we were like, that's got to be in there, right? Now, particular CNI plugins may have, so probably your CNI multiplexer will be able to pass through that information to each additional CNI plugin. Some CNI plugins may have limitations based on IPv6, but I think that if you look at the reference CNI plugins as put together by the CNI maintainers in that community, I think that you'll see strong support for IPv6 in those.
So simply, multiplexers are a way for providing configuration to underlying plugins. And it's up to this plugin if it will support IPv6 or not. And in this area, multiplexers will gather information about what was configured if plugin is returning a CNI result which is correct. And to be more precise, Multus in the mainline has not support to combining results from different plugins, but it has a branch which is providing such option. So at the end, result will have whole information from all plugins running under the hood. And CNI Jenny has this possibility from the start. So, but still, most Kubernetes runtimes are not looking on this result, and they are looking inside container namespace to guess what's configured. So it's kind of out of scope of multiplexers, how it's done between CNI plugin and runtime, how runtime is using this information. So multiplexers are returning CNI result, but it's up to runtime how this information is used. Maybe one another?
Do you anticipate this work and the dual stack work converging together at all? Is it the core underlying problem that both are trying to solve here?
Super interesting question, absolutely. Oh yeah, thanks, Piotr. So the question is, will there be a convergence between the work that's being done in core Kubernetes for IPv6, IPv4 dual stack and the efforts that are being done here? And I think that there are aspects of the dual stack work that are very interesting from a multiple network attachments perspective. I think to me, one of those that's very interesting is this kind of idea of the singular versus plural IP addresses, for example. So something that's been a challenge that we've explored to an extent in the network plumbing working group is the idea of having services on your additional network attachments. And certainly, you know, right off the bat, we took a look at this and we said, well, in a service object in Kubernetes, it's a singular IP address. So I think that there are aspects of both that can interoperate very well and may be very interesting in the future. However, I think that there is a slight difference in the idea of attaching to these networks that may be used, for example, for data plane control plane isolation. I think it is more unique to the idea of a network attachment definition and our specification of that, for example.
And to extend this answer, my proposal is about quite different approach, because I think that IPv6 is a simply different network. So current approach is to have only single or dual stack, but with my proposal, IPv6 will be just another network. So from one end, it's simplification of user interface, and from another, it has to be simpler to use and has to simplify code which is using that. Yeah. So thank you for So the question was how this network object would work and how it's connected with CNI plugins. Sorry, I didn't hear fully that. but we should move this conversation after the session. We will continue that later. So thank you.